So yesterday we have seen how to run a pipeline with the copy data activity. Today we'll be seeing another one activity, that is the notebook activity along with this copy data activity. So we'll have a full-fledged pipeline which will fetch the data from an external source and load the data into Lakehouse, pull the data into the notebook where the data is getting processed and transformed, and the data will be saved into the Delta table. So this is the whole process we are going to do for today. So first thing is, as usual, we need to create a workspace. So I'll give it as pipelines with notebook. So once the workspace is created, now I will be creating a data item, that is the lakehouse, the storage space. I'll give the lakehouse as destination and I'll create it. So now we have created the storage for this workspace. And the next step is we will be creating a subfolder under the files as data ingested, and I'll create a subfolder. And now, as usual, we will start building the pipelines. So first thing is we need to get the data to this target. So our target is a lake house. So the class, this will be the continuation of yesterday's hands-on. So I'll be just moving forward bit faster in the copy data part. Here I'll give it as data movement.
So this
Uh,
is pipeline, oh, Nanda.
yes.
You're creating the pipeline. Okay.
Yes, did it, and I can give it as a data movement. One more thing is transformation, and I'll click on create. This is a pipeline interface, and as we are bringing the data from the external source, by default the copy data activity would have been popped up over here. So as I told you, these are the external resources as shown here, like the SQL Server, SQL, and the file folders from the local device, etc. Now, as even today, we will be getting the data from the GitHub itself. So it is from a HTTP server. So we will just use that as the external data source. Here, I'll be just pasting yesterday's link. So I have pasted the link over here as usual. And here I'll check for the new connection, and I'll give the name for the connection as Lake Destination Connect, and don't worry about the data gateway. And as the data is coming from open source GitHub resource, so it will be anonymous, and the GitHub is also open source and it is public, so it will be anonymous. And I'll go to the next step, that is the connection settings. So the base URL, and as of now, do not worry about this relative URL. We are using the get method to get the data from the external resource. And I will not enable this binary copy because, as I told you yesterday, binary copy is only used for the movement of the data only once in a time. And I don't want to mention any request timeout or maximum concurrent sessions as of now. So here, the file is, as we know, it is an delimited text. If you just give it as a detect format, it will automatically detect, and it is a delimited text. You can preview the data over here. One more important thing, you can check the schema and what is the type of the data type over here. So now, while transforming the data, we have to take care of this data type. Okay, and here I'll just close this preview data, and I have to make sure that,
Nanda?
yeah, please.
Yeah, you said that we need to take care of the data type, right?
Yeah, in the pipeline during the transformation, we can take care.
Okay, okay. Not now.
I'll be telling you how we'll be taking care while doing the
Okay,
transformation.
okay.
First, we'll bring the data to our destination. From
Yes,
here,
yeah,
we can,
destination. Yeah,
yes,
fine. So here the process is ELT, right? Instead of
yes.
E. Okay.
So it is a delimiter. So it's a CSV file, right? So we'll choose here, comma has the delimiter, and here I'll choose the feed to the new line. And as we know, our data set already contains the first row as header. So I'll enable this. I'll not make any changes for this. And coming to the next step. So now it is time to connect to our destination. So our destination is Lakehouse, which is named as a lake destination. So I want this file to be stored as under files, and I will be giving the path over here. So under this, and I'll click on OK. So I'll give the file name as sales only, sales.csv. Here, copy data behavior, I can leave it blank as of now. So the connection is done to the destination. So at what format I need to keep the file in the destination, I want to keep it in the CSV format. So I have to make this row delimiter as a feed line to the new line. And also I can decide whether to have the header or not to a file. So I have decided let the header be to the file and I'll click on next. It is the delimiter text and delimited text, that is the source where we have the data in our GitHub, which is open source, and we are bringing it to the lakehouse lake destination, that is the target, and the file name will be sales csv and the folder which we are storing is data ingest. So we can just start this process immediately. So I'll just click on save and run. We can see whether it has started running over here. So if you just click on this output over here, you'll be able to see the pipeline status of this copy data activity as of now. So it has been, so it's in process. So it should complete the operation with another 10 seconds. So the copy data is now successful. You can just refresh this and check whether the data is sitting over here or not. So this is what we have seen yesterday, right? So the copy, how to copy the data into the root lakehouse. So now I want to use this data in the notebook and apply transformations. So first thing is, in order to apply transformations, I'll be using notebook. I'll come back to my home page. So this is my home page and I'll click on open notebook and I'll select a new note. So this will give me notebook interface. So this will get us to the new notebook interface. So I can just rename this notebook as transform because we'll be doing some transformations over here. Okay, why is it not getting saved? It's taking some time. Okay, let's proceed further. I think it's taking some time over here.
Is this notebook belongs to which lake house it
A
is?
current lake house, the destination lake house layer from the same
Okay,
destination itself. I have created this note.
okay.
Okay. So you can see the data sitting here under this files in the data ingested folder. I think I need to refresh the whole thing. Oh, yeah, here you can see the file. So as of now, I'll just keep aside this and let us start writing the code. So first, I'll just write code. So first thing is I will just name the whatever the table I create. I'll be just giving a table name in initial stage itself as a parameter. So I'll give the table name which has to be saved after the transformation as sales. So, and I'll toggle this cell. Whenever I tell a toggle parameter cell, which means that this cell contains a parameter which is assigned to a value. So here the value is sales and wherever I mention the table name, it will be taking it as sales. It is like a variable. So how do we toggle this cell? So on the right top corner of each cell, you will have more commands. When you click on it, you will be able to see something called as toggle parameter cell. So click on this. When you click on that, you can see that this cell has been configured so that the variables are declared in it and are treated as parameters while running the notebook in the whole pipeline. So now this is treated as a variable name. So how much ever times do you run this notebook? So it will be able to give the name as sales. Now next, I'll start writing the code. PySpark dot SQL dot functions import all the things. Okay, standard session has been connected. Now we can. So if I forget to create the session, it will auto create. It will once I start running the cell. Okay, it gets auto created. So it got disconnected because I canceled the run over here. Okay, now the session is ready. So I can run the cells. So the first cell has run and the second cell is also successfully completed. Now next is I will read data. So basically, I'll be using a data frame to read using Spark. So Spark dot read dot format. So the format is in CSV. It already has a header. So in the option, I'll give it as a header as true. I'll just give the relative path of these. Okay, okay. Let me see if this is the path. Yes. But I'll do a small change over here. I'll just give it as a wildcard entry for this notebook so that I can make this notebook reusable for n number of times to run the transformations on a single file. Now,
Come again once.
why I have given a wildcraft entry in the sense whatever the data I'm getting from my external source, suppose I can think that like the data will get updated every night and it overwrites the data. Suppose today
Okay.
there are 10 rows, tomorrow there will be 11th row, and the whole data is overwritten in the external resource, and I only am copying the data to my lakehouse. In that
Mhm.
case, my name of the file will be same. It will be sales.csv. So I'm telling notebook to read that .csv file under this folder.
Okay.
So even there are any previous old files by mistake in this data ingested, it will be with the sales CSV, or we have to design the pipeline in such a way that we are not supposed to input any other files other than sales data over here. So what I have done is as I know it is already a sales CSV files over here, I could save sales 1, sales 2, sales 3, sales 4, any n number of files with the same data, same column names, but different data, so that the whole for all the files the transformation can be applied. You don't have to worry whether the transformation is applied for this file, and if there are sales 2, sales 3, sales 4 files, you don't have to worry, okay, whether it has applied to the second file, third file, fourth file. You don't have to worry. It will be applied to all the files. That is the major use of the current. So it applies to the all CSV files under this location.
Yeah. Okay.
Okay. So if there are any questions,
So
uh,
the star represents a file name, right?
yes,
Yeah,
any
that
file
makes sense.
name. It can be
Any file name. Yeah.
abc.csv, but make sure that it contains the same columns.
Yeah. Yeah.
Any questions?
So this folder only only have the same type of CSV,
Yes, same
right?
columns. Only that time
Okay.
this will work. I want to
Okay.
apply a transformation for a set of files having the same column names, different rows of data, n number of data, because one CSV can hold, I guess, up to 2000 rows, I guess. For example, take a CSV file, it can hold only up to a certain amount of data. Then you can have CSV1, CSV2, CSV3, CSV4, like sales data 1, sales data 2, sales data 3, sales data 4. But the columns are same. So I want to apply transformations for all the files under that time. You can use this path.
Okay.
I guess doubts are cleared on this, right?
Any other
Yes.
file formats can also be used, right? Excel.
Yeah. I'm taking CSV because it is easily understandable. Even you can take
Okay. By
Parquet
giving only
files.
star dot whatever the
Yes,
format
yes.
extensions. Okay.
Hmm. hmm. Then we'll go forward. Now, next thing is, now I'll be reading the data. Okay, the data has been read. Now, next thing is we need to start our transformation. So,
Nanda, here true is within the quotes. So it should not be right. Dot
uh,
option header true.
here, are you
Yeah.
telling here? I think it's right. It should be in within the
It should
yes.
not be, I think. Okay. Okay. We'll see.
Let us see if it throws an error. No, it's right. Okay, transformation starts here. So, my first thing over here will be I will be adding the month and the year columns for this data set. So let me have, so this contains a sales order number, sales order line number, order date, customer name, email address, item, quantity, unit price, and tax amount. So now we can see the date over here, right? So we will bring the month and the year columns using this column. Okay, there is an order date column replicate which represents this. So using this, we'll be getting the month and the year. So for that, I'll be using the same df, and I'll tell df dot with the column year. I need the year from the column order date. And next thing is I need one more column to be created with the name month, and it should get the month from the column order date to give it in double quote. So we are creating the year and the month column from the order date column. Now let's run this cell. Yes, there are no errors and the transformation has taken place. Now next transformation will be to derive the first name and the last name of the customers. There is a customer name as a single column. I will split that column into first name and the last name. So derive the first name and last name columns. Now write a code to this. So it will be df is equal to df dot same with column. We'll give it as first name, comma. I want to split the column. So I'll use a split function. And the column name is customer name. And I need a space. So I guess it is first name. Then I'll split the column with the customer name. And after this, I will get item as 0. So this will be the first column. So with column again, I need the last name. I'll be splitting the column from customer name dot get. It will be get item with the number 1. So this will be the 0th column and this will be the first column. So it is the numbering of the columns. So its index is 0 and its index is 1. So now I can run this cell. So now the next step is I'll reorder the columns. So in order to reorder the columns,
Nanda, can you see the output, Nanda?
I'll just show you. Okay, you're able to see it over here. All the things will be at the end. So the customer name has been split. So customer name was a single name over here. It has been split as first name and last name. And whatever the year and the month we have created, we are able to see it over here. Okay, why I'm not using display DF is we will be inserting this notebook into a pipeline. Whenever we are inserting the notebook into a pipeline, we can use it for our reference over here while we are trial running it. But make sure that this doesn't include in the note whenever you're pushing this notebook to the pipeline as an
Okay,
activity.
okay.
Okay, so we'll filter the columns and we know there is a customer name column and first name and last name. So let us remove the customer name column and we'll keep the other things. So we'll keep the sales order number, sales order line number and order date. With that, the new columns we have created, that is year and the month, and we'll need first name, last name instead of customer name, and all other things in the same way. That is email address, item, quantity, unit price, and the tax amount. So I can also show you the display too.
So we are not including the customer name, right?
We are splitting the customer name into first name and last name. We are removing that customer name column after creating the new 2 columns. Now we will be able to, I guess I didn't run this cell. Now we will be able to see that we will not have the customer name column because we have filtered the column. Filter option, where I have told only the data frame should contain only these columns mentioned over here. So after the order date, I need the year and month, and then I have removed the customer name and inserted the first name and the last name and reordered it. Basically, it was in the end, right, when we created. Now I have brought it to its own position. Comment this and even this, so that whenever I am pushing it to the pipeline, it should not cause any issue. Now, the last thing is we will load this transform data as a delta table. We don't want the display data to be shown. We want the output to be saved as a table where we can view it in some location. So always remember that try to avoid display DF in your notebook. Even if you use it, just comment it so that it doesn't give any results. So if I just run this cell, there won't be any output for that. I have already commented. Same way, even the other one. So now we have done some transformations by splitting the customer name as first name and last name, and we are bringing the new columns from the date as month and year. Now I want to save all this transform data as a table. So I'll use the same data frame, that is DF, and I'll write it in a format delta and the mode will be append. In the sense, whatever the new data we are going to transform, suppose the file 1 has come, sales1.csv has come. Now the notebook has been, the pipeline run has been taken place, and it has saved this file in the delta format in this lakehouse, and I'll be saving the table name. So as I told you earlier, it is a toggle with a parameter. So here is the table name, and this is the name for the table it should take. So it will take the sales as the table name, and it will load to the table. So now what happens is, when you run for the first time, the data will be saved in the sales table. Second time when I run it, I want the data just to append. I don't want the data to erase and overwrite. So I'm using the mode as append. So there are various modes, like you can overwrite the data or you can append the data. So these are the two options. So I want to append the data. I want, like, if there are 10 first CSV file. So tomorrow when I come and run the second CSV file, which I have copied from the external source, it should only append those next 10 or 20 rows which are coming tomorrow to the same table. So that is the mode function which takes care of it. So I'm telling to append. So if I give here it as overwrite, it will overwrite the previous file, previous table itself. That is the function of this mode, and it will be saved in the table name. So table name, as I've told earlier, it has been mentioned in the toggle bar, and it will take it as a sales. So this is the set of transformations we have done, and once you run this, you will be able to see the table under this. The jobs have started running. Yeah, now if I refresh this, I'll be able to see the table over here. You guys can see the sales table over here, and also you can preview it in the lakehouse. So along with the columns. Now we are done testing this code. Now what I'm going to do is, I'm going to pull this notebook in our pipeline canvas. So it will be something like from the copy data activity, the next activity will be the notebook activity for the pipeline. So it will undergo this transformation, and then it will save it in a table. So now I have the table has been already created. What happens now is, when I run the pipeline by putting this notebook, it is going to just pull the data and append the data to this. So what I'll do now is, I will just delete this table sales. And in this notebook, I will just have to clear all the outputs. So to make sure that just clearing all the outputs of the cells. Okay, now the notebook is ready. We'll just save it as transform data, and I'll save this. Coming back to our pipeline where our copy data is already there. Now we will bring the notebook activity over here. So while building a pipeline, there are n number of activities. Like if you click on this activities, you'll be able to see copy data preview, data flow, notebook, metadata, lookup, script, stored procedure, then variable setting, for loop, if conditions, and web, then invoke a pipeline inside a pipeline, then schematic model refresh, and running the external workloads on this pipeline. All the options will be there, and there are n number of activities also. So now I'll just add a notebook to my canvas. So once I have added the notebook over here, I'll keep the name of this activity as notebook 1 only, and I'll keep all the other things as the same. Like the activity state as activated, and timeout as the 0.12 nanoseconds or microseconds. Let it be anything as default. And now in the settings, I'm going to, like, we need to choose the workspace, and now I'm currently in my workspace itself, that is pipelines with notebook, and now I have to choose the book. So I'll be choosing the transform data notebook, which I've saved recently, just a couple of seconds or a few minutes before. And nothing to add has a base parameters or a session tag as of now. And the next thing will be connecting this copy job to this notebook. So I will just name this copy jobs as data ingestion of data, and I will name this notebook as transformation of data. So just give underscore. So it will be good. Now we can also add the delete activity as I specified to you in the yesterday's hands-on. So I'll just search for the delete data. Okay, it's here, and we can put it before the copy data so it clears the lakehouse. So I want the lakehouse to be clean, and I'll put it as deletes the old data in the lakehouse. So I'll just connect this to this. Okay, I have to make some more settings. So in the source, I will select a connection. So I'll use the same lakehouse connection, which I'm able to see it over here. And I'll select the lakehouse. So this was just the connection. Now I'll be using the lakehouse name, that is lake destination. And here I'll give a wildcard file path. So I'll just take this folder and I'll click on OK. So the files and the subdirectory is ingested. Now I'll give the wildcard file name, that will be star.csv. So any CSV files inside that will be cleared. So I want this to happen recursively whenever I run this pipeline. And in the load settings, I don't want any logging to be done as of now. So I'll disable this logging. Yes, we are good to go. Now we will save the pipeline. And next step is we'll validate the pipeline. So there is no errors in the pipeline. Now we can trigger this, or trigger is nothing but running the pipeline. So I'll use this time the trigger. Okay, here we don't have a direct trigger option. I can use this run option as. So yes, the pipeline run has been started. Can just close this. Remember to save your pipeline before you run. Otherwise, the activities wouldn't have been saved. Whenever you initiate the run, it will fail. The pipeline would fail. So first activity has been succeeded. Now coming to the second activity, that is the copy data activity, ingestion of data from the external source. That is in queue. So it's in progress. It's done. The ingestion is also done. Now it's time for transformation. It has failed. Let us check why it has failed. Okay, there is a problem with the file. Let's check. Okay, I didn't turn on the session in the thing. So I'll just give my old file only, that is the transform file. I'll just remove this transform data. Let me check, go back here, go to the settings. I'll just change it to transform. The first notebook, whichever I have created. So I have saved the notebook twice, and here I have not started the session. So that might be the problem. So let me just save it now and validate it. So there are no errors, and I will run this again. I can see the session has started over here. I think I need to add a base parameter too, because I have given the toggle as table name. It is of string and the value as sales. So if this time the pipeline fails, there is some problem in the Spark session creation. Here in the notebook, make sure that you have to disconnect with the Spark session before you run with the notebook. The Spark session here should be disconnected, otherwise the capacity load will be completely bound to this notebook. So that when the Spark session is connected to this notebook, apart from this pipeline, the whole capacity is acquired here. You need to free the capacity for this session. So you need to stop the session here. So it should not be connected, and then run the pipeline. So just run the pipeline. You will be able to see the pipeline run successful. So the error was due to the capacity, high time of the capacity of the Spark session that was created. So I have to disconnect the Spark session and then run the pipeline. So now the pipeline is running well. You can see that the notebook is also in progress. This might take some time to run, but it will be successful. So you would see on the screen now that the notebook run will be successful. Sometimes takes up to a minute to run. You need to wait until the run is complete. It takes some time in the notebook because it has to start the session on its own, run all these cells, and push the data. So now you can see the notebook run is succeeded. So this is all about the pipelines.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.